Hello, dear viewers and dear students. Welcome to my YouTube channel, JZ Knowledge. I hope you all students will be fine, and I'm enjoying my these videos. Dear students, I had started a lecture on biochemistry on this YouTube channel, JZ Knowledge. I discussed different introduction of carbohydrates, then different classification of carbohydrate like monosaccharide, disaccharide. Now in this video, I will go and discuss reducing sugars. That what are reducing sugars and how reducing sugar reduce other compounds and make acetal and hemiacetals. So reducing sugar is any sugar. Before starting my this lecture of reducing sugars, I first kindly request you to please subscribe to my YouTube channel JZ Knowledge to get my upcoming videos. So dear viewers, reducing sugar is any sugar that is capable of acting as a reducing agent because it has a free aldehyde group or a free ketone groups. All monosaccharides are reducing sugars along with some disaccharides, some oligosaccharides and some polysaccharides. The monosaccharides can be divided into two groups, the aldoses which have an aldehyde functional group and the ketoses which have a ketone functional group. Ketoses must first automerize to aldoses before they can act as reducing sugar. So for ketoses to act like a reducing sugar, they must change into aldehyde functional group to become a reducing sugar. Disaccharides are formed from two monosaccharide units which we already discussed in the previous lecture and can be classified as either reducing or non-reducing sugar. So disaccharides are made from two monosaccharides and can be classifying as reducing or non-reducing. Some are reducing while some disaccharides are non-reducing. So non-reducing disaccharides are sucrose and trehalose, which have glycosidic bonds between their anomeric carbons and thus cannot convert to an open chain form within aldehyde functional group. They are stuck in the cyclic form. Reducing disaccharides like lactose and maltose have only one of their two anomeric carbons involved in the glycosidic bond, while the other is free and can convert to an open chain form within aldehyde functional group. So for reducing sugar, their anomeric carbon must be free. One anomeric carbon must be free so to reduce the other compound. Reducing sugar have an aldehyde group in open chain form. In open chain form, reducing sugar must have an aldehyde functional group like a monosaccharide like glucose, fructose, glycerol aldehyde, galactose, while in disaccharide like lactose and maltose, these all have aldehyde functional group in open chain form and are reducing sugar, while some non-reducing like disaccharide are sucrose and trehalose. So sucrose and trehalose both are disaccharides and both can act as a non-reducing sugars. So reducing sugars react with a substitution reaction of nucleophile. So nucleophile are those species agent which can substitute a molecule of positive charge and act as a nucleophilic substitution reaction. So upon Upon nucleophilic substitution reactions, acetyl and hemi and full acetyl and kettle are formed from the non-reducing sugars. Like aldehyde will form hemi acetyl and acetyl, while ketone form kettle and hemi kettle from when react with nucleophile and make these acetyl and hemiacetyl and kettle and hemi-kettle. So if we talk about the physical properties of monosaccharide and disaccharides, so monosaccharide and disaccharides both are crystalline solids. There are two types of solids. One is amorphous solids and the second is crystalline solids. Amorphous and crystalline solids both are compact solids, rigid solids, but crystalline solids have a proper geometry, while amorphous solids don't have any proper geometry. So monosaccharide and disaccharide are crystalline solids, while polysaccharides are amorphous solid. Amorphous solid mean they don't have any geometrical shape, and both monosaccharide and disaccharide are soluble in water, while polysaccharides are insoluble in water. So example of these are glucose, lactose, sucrose. These are monosaccharide and disaccharide, so these are very easily soluble in water. But polysaccharide like cellulose, chitin, and some other example of polysaccharides are non-soluble in water. Polysaccharides are tasteless, they don't have any taste. Mono and disaccharides are sweet and taste, like lactose in a milk is sweet, fructose sugar is sweet, glucose sugar is also sweet. And while polysaccharides, just like chitin, just like cellulose, and just like some other sugars, polysaccharides are tasteless, they don't have any sweet taste. So monosaccharide and disaccharide are low molecular weight. Low molecular weight because monosaccharide have only one glucose subunit or one fructose subunit or one galactose subunit, and disaccharide have only two. So their molecular weight is very low as compared to the polysaccharide, because polysaccharides are made from many monosaccharide units. So that's why the polysaccharide have high molecular weight, while mono and disaccharide have low molecular weight. So this is all about the dear viewers, this is all about the reducing sugars and the physical properties of glucose, physical properties of carbohydrates. In the next lecture we will discuss the chemical properties of carbohydrate. So keep in touch with our YouTube channel JZ Knowledge by subscribing our channel and press the bell icon to receive the notification of our latest video. Thank you so much for watching my video.